Okay, so we're starting today with trying to understand something that it's called ventilation perfusion ratio. And we're not only trying to understand what it is, but we're also trying to measure it. And when we measure it, we are obviously we're going to get a value. So we want to make sense of that value and what we actually could understand out of that value, or what this value could indicate. And before we get into ventilation perfusion ratio and how we can measure it, first of all, let me just say that ventilation perfusion ratio is just a very, 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 very small baby of a very big mother concept. This big mother concept that I just mentioned it's a concept that humans have created, and we created it to understand the world around us. It helps us to do a lot of things. It helps us to understand. It helps us also sometimes to predict things. So this concept, we have been able to evolve it and to make it better and better and to use it more and more. And this concept, you may have guessed it, it's just the big concept of numbers. And actually, ventilation perfusion ratio is just a very small baby, as I said before. It's a very small equation in the numbers world, but it has its importance, and it actually could help you in understanding a lot of diseases. And actually, it may not have a very large role, but it can give you a very deep understanding of some diseases. Okay, so first of all, before we get into the measurement of this ratio and how can we measure the values that gives us this ratio, let us start first of all by just understanding these three words. Let us just break down this sentence and try to understand it. First of all, let's start with ventilation, because ventilation sometimes you can misunderstand, or you can just confuse yourself between ventilation and respiration. So let me just make it very clear. Ventilation is the process of breathing, of inhaling and exhaling, of process that you will get fresh air from the environment into your lungs. Okay, so this is the process of ventilation. The process of respiration is actually a longer process. It's the process of getting fresh air outside from the environment into your lungs. But it doesn't stop here. It actually goes on, and it says that this actually fresh air is going to reach the cells, and the cells are going to use it, and they're going to give you carbon dioxide, and then you're going to exhale that carbon dioxide. Okay, so respiration is actually a bit more longer than ventilation. So let's look up ventilation. It's right here. So as I said, ventilation is just the process of breathing. Okay, and a very important word that I want to highlight, which is fresh air, because when you're in a burning building, for example, there's actually no fresh air, there's no oxygen, so you're not actually ventilating. But you need fresh air to say that this person is ventilating. Okay, so this is the first word. We understand what ventilation actually stands for. So let's move on into the second word, which is perfusion. The perfusion, the word itself, it just means the passage of fluid through an organ or through a tissue. And in our case, we actually specify these two things. We specify what type of blood we have, and we specify what type of organ we have, because ventilation perfusion ratio is something that you measure in the respiratory system. Okay, so in our situation, the fluid that is going to pass our organ is the blood, and our organ is the lung. Okay, so after that, now we understand the two words. And ratio is just a value between two numbers. You take two numbers, like for example A and B, and you divide them, and these two numbers are going to give you a value. Let's say for example X. Okay, And in our situation, what we want to know today is that we want to know what A stands for, how we can measure A, and how can we measure B. And when we divide them, they're going to give us a value. So this value, we actually don't know it yet, but this value, when we have it, we want to know when it's normal, and we want to know when it's increased, and when does it decrease. And not only that, but we actually also know what are the reasons behind that. Okay, so this is our simple equation for the whole video of today. So after that, we understand now the basic words of what we're talking about. Let's move on into trying to measure, to find out what is the value of A and what is the value of B, or in our situation, what is the value of V and what is the value of P. And let us start with the value of P, because it's actually just a number, a standard number. And this standard number, you can see it right here. You can see right here the cardiovascular system. And in the cardiovascular system, you have your heart, your veins, and your arteries. And your heart is able to pass fluid, as we said, through your lungs. And actually, not only through your lungs, but through your whole body. Okay, so the amount of fluid that, or the amount of blood that the heart is able to pump is actually, they measured it in 1 minute. They said that it's 5 liters per minute. Okay, so this is the value, and if you wanna imagine how much this value is, if you ever saw a family-sized soda, which is 1.25 liter, actually your heart is able to pump 4 of them in 1 minute.